Still running the NGINX Ingress controller in production? In a few months, that controller may stop getting fixes and your cluster could be exposed without you realizing it. In this video, you'll see exactly what's changing and how you should plan for the future to stay safe and secure. Let's get started. The Kubernetes SIG Network team recently announced the retirement of Ingress NGINX, a very popular Kubernetes Ingress controller. We will discuss everything you need to know about this change and how you should plan in future. Ingress is the original user-friendly way to direct network traffic to workloads running on Kubernetes. However, the Kubernetes SIG Network team recommends to migrate to Gateway API, which is a newer way to achieve many of the same goals. We will provide a comprehensive guide for DevOps engineers and Kubernetes administrators navigating the transition from Ingress NGINX to Gateway API. Kubernetes Ingress is a powerful mechanism for routing traffic to services within a Kubernetes cluster. It sits at the edge of the cluster, handling incoming HTTP/HTTPS requests from external clients. The Ingress resource defines the routing rules, things like host names, paths, and which backend services to send traffic to. The Ingress controller is responsible for implementing those routing rules and configuring the load balancer accordingly. Once traffic reaches the Ingress controller, it is forwarded to the appropriate Kubernetes services based on the defined rules. This allows for flexible, scalable, and centralized traffic management within the Kubernetes environment. Let's we have an Amazon EKS cluster or any Kubernetes cluster, and the Ingress controller is deployed as add-on into the cluster. The Ingress controller is nothing but another pod running in the cluster and watching for Ingress object types. This Ingress controller can be NGINX Ingress Controller or AWS Load Balancer Ingress Controller. In this case, let's assume that AWS Load Balancer Controller is deployed into the EKS cluster. The Ingress controller keeps watching for the Ingress objects to take action, that is to create application load balancer. Now let's deploy two Kubernetes services into the cluster. These are cluster IP services. That means they are accessible from clients which are within the cluster. So the external clients outside of the cluster cannot reach these services. That's where the Ingress object helps, which brings traffic from outside of the cluster to the services running inside the cluster. Now, when we deploy the Ingress object into the cluster, the Ingress controller immediately takes action by creating AWS application load balancer, target groups, listener rules based on the Ingress specification. Please note that the AWS application load balancer created here is fully managed by Ingress controller and very much ties to the lifecycle of Ingress object. So if you delete Ingress object, the AWS load balancer controller deletes the corresponding AWS application load balancer automatically. Now, the external clients on the internet can make calls using the DNS name, say example.com, which is defined in the Ingress object. The Ingress object can also specify a TLS certificate to terminate the TLS or the application load balancer. DNS resolves the domain name to the IP addresses of the application load balancer. The application load balancer receives the request and try to match it with any of listener rules configured. These rules can include domain name, path prefix, or headers. Once a match is found, it forwards the request to the appropriate backend service pods in the target group. There are a variety of Ingress controllers available in the Kubernetes ecosystem, each with their own unique features and considerations. There are popular options which are some of the most widely used Ingress controllers, including Ingress NGINX, AWS Load Balancer Controller, Traffic, JProxy Ingress, Contour, and Kong Ingress. Ingress NGINX is a popular choice, but it's important to note that it will be retiring in March 2026, so organizations may want to consider alternative options that have longer term support. There are few key considerations we need to keep in mind that highlights important factors to evaluate when choosing an Ingress controller. This includes cloud provider integration, specific feature requirements, performance needs, maintenance support, deployment environment, and community activity. Now let's get the facts right about Ingress NGINX retirement announcement to avoid any confusion. The NGINX Ingress controller is being retired in March 2026. The best effort support will continue until March 2026, so you have some time to prepare for the transition. From that point on, there will be no further releases, bug fixes, or security updates. Basically, the Ingress API will be frozen without any new development. However, existing deployments will continue to function and installation artifacts will remain available. However, please note that Ingress API is not going away. It will continue to exist, and only the NGINX Ingress controller is retiring. It's critical to check if your Kubernetes cluster is using Ingress NGINX, as you will need to plan for its retirement. Let's understand some background context as to why is this happening now. There is a lot of maintenance burden, as only 1 or 2 maintainers are working on this project after hours, which is not sustainable. Despite the project's popularity, there is insufficient community support to help with maintenance. There is a technical debt angle, where the flexibility that was built into the project in the past has now resulted in security flaws. Certain snippet annotations that were previously considered useful are now viewed as vulnerabilities. The Ingate project, intended to replace the current solution, never fully matured. The announcement of the Ingate project did not generate the needed support from the community. The Gateway API is a modern replacement for legacy Ingress controllers, providing a more robust and flexible architecture for managing traffic in Kubernetes environments. It features a role-oriented design, separating concerns between infrastructure providers, cluster operators, and application developers, allowing each to focus on their specific responsibilities. The Gateway API is portable and expressive, with a standard specification that supports multiple implementations and native header-based routing, making it easy to use and customize. The extensible architecture of the Gateway API allows for the creation of custom resources at various API layers, enabling granular customization to meet the specific needs of your application and infrastructure. Let's now understand few key differences between Ingress and Gateway APIs. The Gateway API approach introduces an additional layer of abstraction and role separation with the Gateway class, Gateway, and routes resources. This added flexibility and extensibility makes the Gateway API a more powerful and future-proof solution compared to the limitations of the Ingress resource. Ingress is a single resource type with limited protocol support and annotation-based extensions. Gateway API introduces a more flexible and extensible architecture with multiple typed routes, HTTP, gRPC, TCP, TLS, and native extensibility. Gateway API also provides cross namespace support, allowing for more advanced networking configurations. Now, one of the most important questions you may have is, what happens to the AWS load balancer controller? Will it exist, or should we look for alternatives going forward? The AWS load balancer controller is an official AWS solution that continues to exist. It provisions AWS application load balancer for Ingress resources and network load balancer for Kubernetes services of type load balancer. The best part is that it will provide dual support for both the Ingress API and the newer Gateway API. This ensures it is future ready, with new features being ported to Gateway APIs going forward. The AWS load balancer controller is the primary recommendation for AWS environments. The another obvious question now is, what about VPC Lattice then? VPC Lattice is an application networking service for service-to-service communication within and across VPCs and accounts. It provides service mesh capabilities without the need for sidecar proxies. Key features include cross VPC and cross-account connectivity, built-in observability and security, and integration with AWS Gateway API. VPC Lattice is best suited for east-west traffic between services, complementing Ingress solutions for north-south traffic.